Good afternoon. So this is our sixth lecture of Development and Growth 2. And today we are going to start discussing technological progress and productivity change in an economy. In this lecture and the following two lectures, we spent some good time on understanding some models of endogenous technological progress. And more generally, we want to understand how productivity changes in an economy. So let me open my whiteboard and start the lecture. There are still people joining. Okay, so okay, let me share it. So this is lecture 6, technology and productivity. Okay. Now, in general, we have three types of productivity change. Okay. So one is sectoral reallocation of resources. Okay. So for instance, if you have agriculture and manufacturing in the economy, okay, and if manufacturing is more productive than agriculture, okay, in terms of output, let's say, then if your resources, your labor, your capital, and other resources, if they are transferred in time from agriculture to manufacturing, you can have a productivity gain from this sectoral reallocation, right? It doesn't have to be agriculture and technology. It could be more generally low productivity sectors to high productivity sectors, right? Suppose that there is trade liberalization, okay? So what is the effect of, let's say, suppose that there is a tariff reduction, okay? So what's the effect of this? Well, many industries are now open to global competition, right? Some low productivity firms, go bankrupt, right? And then there could be some productivity gain associated with this because now only the high productivity firms survive. Okay, so this means their resources are transferred. So the low productivity firms are no longer operating. So there could be then a productivity gain associated with this reallocation, okay? Reallocation of resources. Now the second reason or the second mechanism is what we call innovation. Innovation of new technologies or new products. Okay, so why innovation is important? Well, you can imagine something like this. Suppose that I write our production function in the following way. This is actually what I discussed today in my PhD class. I will explain these terms in a moment. Now, Y is of course output, right? L is labor. M is the number of machines, number of different types of machines, right? So we index these machines in this particular way. Okay, so there's an infinite number of machines actually, but their total mass is M. So if you don't like the integral term here, you may write it in this particular way as well. So you may suppose that these are discrete machines, right? You can also write this and their equivalent. A or AI is the productivity of machine I. Okay, so what does this mean? Well, each machine I has come with a productivity. Okay, and productivity can change in time, as you said. I will explain how the productivity of such intermediate inputs or machines can change through innovation. And finally, Xi is the total units of machine you employ, total units of machine I. Oops. Machine I employed in production. So what does this production function tell you? Well, there is labor, as usual. Okay, so people work, but they work these machines. So how many machines in total you have? Well, you have M different machines. Okay, each of these machines each of these machines comes with a physical unit. So let's say 5 machines from machine I, 6 machines from machine J, etc. Right? There are many machines, and each of these machines, or intermediate inputs, or tools, or equipment, whatever they're called, they also have, each of them have a particular productivity for your production technology. Now, within such framework, what is technological progress? Okay, technological progress, let me use this area for the figure. So we understand technological progress or innovation in 2 dimensions. Okay, so on the horizontal dimension, we have the machines themselves. Okay, and on the vertical dimension, we have the productivity levels. Okay, now at any given time, these machines have a productivity distribution. Okay, so they have different levels of productivity. Okay, so they have different levels of productivity at time t, right? So this is 0, this is mt, and each machine has a particular level of productivity that we show on the vertical axis. Now, there is one type of innovation where the number of machines increases. Okay, and this is called horizontal innovation or product innovation. Okay, so if new firms are opening, okay, new machines are discovered, okay, new markets are opened. So this type of innovation is called horizontal or product innovation. Okay, and these new firms, suppose that they enter with some random productivity, right? Now, in the meantime, there is also what we call vertical innovation. Okay, because each and every firm also try to increase their productivity. Okay, sometimes the incumbent firms, you know, there's a difference between entrant and incumbent firms, right? You know this from your micro classes, I guess, or industrial organization, right? So there are entrants and incumbents. Sometimes the entrants are creating better versions or higher productivity versions of these machines, so they replace the original monopolists that produce such goods in that sector. Or sometimes the incumbent firms, they have themselves their R&D labs. In their R&D labs, research and development labs, they try to improve their products, right? So this is called vertical or process innovation. Okay, vertical or process innovation. So in time, what happens? In time, technology progresses in this dimension, right? So on the horizontal dimension, there are new firms, new machines, new intermediate inputs invented and developed by entrepreneurs. Then on the vertical dimension, there are always better versions of, there are always better versions of existing products. Okay, higher productivity versions. So technological progress through innovation has this particular two-dimensional setup. So if you want to find a measure of technological sophistication and economy, you can perhaps approximate that through this rectangle, right? So there are M firms and the average productivity is A, okay? So A bar times M, or some function of A bar and M could be telling you something about the technological sophistication of a particular economy. Okay, so that's the second mechanism, and it is of course a little bit more complex than the sectoral reallocation, right? And finally, the third mechanism is technology adoption. So what is technology adoption? Technology adoption is using technologies. When I say technologies, I mean both products and processes. Okay, using technologies innovated by other countries or other firms, or I mean other regions. So this could be at country level, regional level, sectoral level, or firm level. What is important here is that, of course, we are looking at the country level. So we understand that there is an innovator country or a number of countries that are already innovating new technologies through product innovation or process innovation. And in time, our country, the country of interest, okay, the firms in this particular country, they try to adopt these foreign technologies or frontier technologies, okay? When they do that successfully, there is also productivity gain. Okay, so when a country successfully adopts technologies, they also create productivity increases. Now the idea of technology adoption can be summarized in this way. So suppose that this is time, and let's say this is the natural logarithm of productivity in the United States. Okay, so United States is an innovator country okay, and the productivity, some sort of productivity variable in the US exhibits that continuous increase because of, let's say, innovation. Okay, now imagine that the other country is Korea. Okay, and suppose that this is perhaps 1950s, and suppose that this is 2010. Okay, now in 1950s, South Korea is definitely a lower productivity country relative to US. Okay, but what happens after 60s? They make some successful technology adoption. They implement some successful technology adoption practices, and eventually they converge. Okay, they converge to US, and after some point, such as this, okay, so suppose that this is 1960, this is 1980, and suppose that this is 1990. At some point, they itself, I mean, Korea itself becomes an innovator, right? Because it is now sufficiently highly productive. So the idea is that a country usually starts as a technology adopter. Okay, they try to transfer these technologies from abroad, and at some point, once they become sufficiently productive, their technological capabilities are large enough, so they have high enough human capital, they have trade openness, okay, they have trade openness, they have other factors, so eventually they start innovating themselves. Okay, so in that regard, so if you think of so this is actually one of my papers. This is actually from one of my papers. So if you look at 3 countries, this is again, so you can actually draw the same graph for output per capita as well. So US is like this, Turkey is like this, and Korea is like this. Maybe I can do this. So, oops. Korea is like this. So this is Korea. Okay. So initially, this is again log, of course. I mean, natural logarithms. Okay. So initially, Korea is poorer than Turkey. Okay, but in time, they forge us ahead. So again, this is perhaps 50s. This is perhaps 70s, and this is perhaps 80s. Okay. So you can actually find this paper in my website and try to you know, I mean, you can read it and learn a lot of stuff about the Korean miracle. Okay. So let me summarize. So first, we started thinking about productivity increases in an economy. And there are 3 mechanisms: reallocation of resources, reallocation of resources from low productivity to high productivity, okay, to innovation. There's process innovation, and there is product innovation. And 3, we have technology adoption. Okay. Now, what I will show you in this week and in the next 2 lectures is to understand these mechanisms. Okay. We want to understand these mechanisms. So let me pause here for a moment, and if you have questions, I can answer them. So that was the first part. Anything? Great. So let's think of this sectoral reallocation issue. Okay. I'm going to show you a very simple model for this purpose, and I'm not going to solve it, but show you some of the mechanisms so you can maybe try solving it. Suppose that there are 2 sectors. Okay. Let's call these sectors traditional and modern. Okay. There is one traditional sector and there's one modern sector. Okay. And let's write these production functions in this way. So there is traditional technology that uses, let's say, labor. Okay. Suppose that sector uses labor, and there's this suppose that labor exponent, and there is a productivity that is fixed in that particular sector. Here I assume that there is decreasing returns, so this sector is traditional in that particular sense. Okay. And suppose that there is also modern technology. Modern technology has also this particular level of productivity, AM. Okay, so here AT bar is positive, and here, of course, this sector uses also labor. Let's say, suppose that there's no physical capital. You can add physical capital to this model, but in this sector there is constant returns to scale. Okay, so in the traditional sector there is decreasing returns to scale, and in the modern sector there is constant returns to scale. Okay, and here a M bar is also positive. Now our critical assumption is that modern technology is much more productive than the traditional technology. Okay, so finally the last equation for us to define to complete the description of the economy, let's suppose that the total labor force is given. Okay, suppose that it's equal to 1. So this could be any number, right? I mean, I'm just making this up. So obviously the problem that this society faces is how to allocate resources, right? How to allocate labor in these 2 sectors. Okay, and that of course will depend on the productivity parameters. Now here I'm completely assuming demand. All right, suppose that they are producing the same good. All right, so suppose that they are producing the same good, and since total population is equal to 1, these are also per worker levels, right? These are also per worker, because here I am simplifying a lot of stuff. I want to show you the main mechanism. All right. So the problem, if you think of this a little bit more carefully, the problem the society face can be written in this way. So suppose that the society wants to maximize total production. Okay. So then you have something like this. LT alpha, a M bar, and then you have 1 minus LT, right? Because this is now total production, okay? And we can choose LT because this is a well-defined, concave optimization problem, right? So the objective function is concave. So you can actually write a first order condition. Okay, remember this from your micro classes. So you are taking a derivative with respect to L. Then you have a bar T, right? LT alpha minus 1 minus AM. Okay, and if this is interior, right? I can equate this to 0 by assuming that there will be always some workers employed in the traditional technology, because its marginal productivity goes to positive infinity when LT goes 0, right? So the marginal productivity in the traditional sector goes to positive infinity, as you see, when labor goes to 0. So there will always be somebody working in the traditional technology, in the traditional sector. So what the result looked like? Well, it looks like the optimal allocation looks like this, right? So alpha a T bar divided by a M bar 1/1 minus alpha. Okay, so what does this tell you? It tells you that if manufacturing sector productivity is getting larger and larger, okay, then more of the workforce will be employed in manufacturing, of course, right? Because this is the productivity in the modern sector, right? I'm sorry, I misspoke, not manufacturing. Here I'm calling them traditional and modern. So do you see it, right? So if this ratio is getting smaller, why? Because AM is getting larger and larger, and AT, suppose that is fixed, then LT also gets lower. So optimally, the society should transfer labor from traditional to modern sectors, and there will be a productivity gain, right? Because you are using your resources more in the productive sectors and less in the unproductive sectors. To also see how does it play, you may also imagine this. Remember the production functions. So you have traditional technology times labor employed in traditional technology, and you have the modern technology, and you have that. And in total, they must be equal to 1. So suppose that you put all your resources into traditional technology, right? So equilibrium 1 is LT equal 1, LM equals 0. So what's total production? Well, you have A bar T, right? That's total production. In equilibrium 2, you put all your resources into manufacturing. I misspoke again. So to the modern sector, okay? So what's your total production then? Well, it is equal to A bar M. You see? So, so this will be 1. So as you see, if you move the resources away from the low productivity sector, you create a productivity gain in that macro sense, okay? And if you think of more in more realistic terms, modern sectors are called modern because technological progress is faster. Okay, in such sectors. And here we also use decreasing returns in one sector and increasing constant returns in the other sector. So there's already an inherent difference, inherent heterogeneity across sectors, but in general that could create in time some productive. So there is no technological progress in this economy, right? This is fixed, but just because you move labor from traditional to modern creates a productivity increase. Okay, so let's stop here, and if you have questions I can answer them. Okay, so do you remember there was this paper by Lucas we studied in the previous semester? Remember that countries, so it was like a Lewis model, right? So countries were transitioning from one equilibrium to another equilibrium, so the labor share in agriculture decreases, right? Remember that figure? So I will show you some figures. I did show you some figures. So that type of situation is actually occurring here, right? So from agriculture to manufacturing, or from agriculture to services, labor is moving from low productivity to high productivity sectors. So there's this pull effect by the modern technologies. In equilibrium, so it is equal to 1. I corrected that, Özgür. I corrected that. It was a typo. So in equilibrium 2, LA is equal to 0, LM is equal to 1. Any other questions? Okay, so that was the first mechanism I wanted to discuss. In the next hour, in the next session of today, I'm going to discuss innovation. I'm going to start discussing innovation, and then we're going to continue. Okay, so let's take a break now. Let's meet at 1:55. Okay, after the break. 1:55. Okay, bye bye.